Hello, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to part 2 of Intermediate R. Now, the material is here at chriswoods.com/intermediate R, and we're on this page now, string formatting. Now, being able to print things to the screen is a fundamental part of interacting with a programming language. Now, so far, we've kept things simple. So if we go back to our R workshop, our RStudio screen, say I create a number which we're going to assign from 42. And when we wanted to print it, we just used the print function. So print mynum, then printed 42 to the screen. Now we did make things a little bit cleaner at the end of the beginning R workshop where we used cat. And what cat did is it basically printed just the item to the screen without that little square bracket one, which is a little cleaner. And indeed, we then improved things a bit more by recognizing that cat allows multiple arguments to be printed. So for example, I could do cat my num is, comma, my num, comma, and then a new line, and then hit return, and we can see my num is 42 is printing to the screen. And remember, this \n means new line. Now this worked perfectly well, but there's a few things which are less satisfactory about it. One is we relied on there being a space between my num is and my num, and this was automatically added by the cat as part of the sentence, but you're kind of assuming that it's going to be there. And the other thing is that we have effectively, this is one line, my num is 42, but we're trying to put it in with 3 different bits of data: the string, the actual integer number, and then the new line character. It'd be much better if we could combine all of these things into one and have much more control over the formatting of it. And this is really where the C-style formatting comes in. So sprintf is a function which provides C-style formatting. So this is formatting of strings, which was inspired by the C programming language. If we just take a look at the help of this, you can see here we have lots of descriptions about how it will work. Now what you pass in is you pass in a format string and then some data. Now, how does this go? Well, let's see. If we put in here cat sprintf, first we're going to start with a format string, and this is what you want to print. So for example, my num is, but then you put placeholders within this string for the data which you're going to be copying in. So in this case, %d is a placeholder which is there ready for an integer, which is a decimal number, hence why it's %d. And then we do \n to end the line. Now after the format string, the second argument you place in are the variables or other variables that you wish to actually input into the string. So in this case we want to put in my num. Now if I hit return, you can see it's now printed my num is 42. What this has done is that the value of my num, which is 42, is placed into the first placeholder within the format string. So it's put in and replacing this %d. Now the %d means format this digit as an integer or as a decimal. Now we could have chosen other format sort of types as well. So for example, let's create a floating point number, which I'm going to assign from the number 3.14159. Now I can print here cat sprintf a digit. So a digit, remember, is a %d, an integer. But a floating point number will be a %f to mean floating point. Then we close double quote, and then we put in now all of the variables we wish to substitute in. So this is going to substitute my num into the %d and my float into the %f. So there we are, we have a digit 42 and a float 3.14159. Notice that the 0 has been added onto the end, so our float was only 3.159, but this is now made for 3.14159. That is because this has been printed with 6 decimal places. Now we can control the actual width and the number of decimal places used by adding in numbers. So for example, if we do cat sprintf and then we do width 8, so we want to write an 8-character string with say 3 numbers after decimal place. So this is just the string we're putting in first. The format string we would then use would be % and then 8.3f. That means an 8 width, 3 numbers after the decimal point, floating point number. And then I'll pass in my float. And what we will see here is it's now printed 3.142. Here we have the 1, 2, 3, 4 5, 6, 7, 8, and then there are 3 numbers here after the decimal point. Now, there are a lot of controls and lots of abilities for you to actually play around, and as you'll see here in the notes, if I just scroll down, we have linked to handling strings with R, which provides a lot of background if you want to really get into how do I format my strings and how do I really control the numbers that are coming out. Now, we've been using cat so far to write text to the screen, but we can actually use cat to write text to a file. Now we do that by using the file operator, or the file argument, sorry. So let's imagine now I'm going to cat a string and I'm going to write this new string and call it writing to a file. Now if I just wrote this like this, it would print it to the screen, as you can see here. But if I now pass in an argument using the file argument, I can tell it to write this text to a file. In this case, I'm going to write it to output.txt. Now, how do we know that's worked? Well, let's look in the file browser. And if I look down here, here is output.txt, and when I click on it, it's now open, and we've got writing to a new file. Now, if I run this command again, I'm going to write another string. So let's do writing to a file again. And now I press return. You can see what's happened is it has overwritten the contents of output.txt. If we wanted to append, we wanted to add a new line to this file, we need to have the append argument as being true. So I'm going to write another line, so it'll be again, and I'll do yet again. And there we are, it's now appended that line, and if I keep running this command, notice I'm using the up arrow to access my last command. You can see I'm now writing and appending to this file. So this now brings us down to the exercise. What I'd like you to do is I'd like you to look through the handling strings with R and just basically play around with different formatting types and formatting different variables into different strings. And then when you've completed that, have a go at writing text to a file. And again, just like I've done, have a look at the text being written live by opening the file by clicking on it in the Files pane on the bottom left. So click pause, and that will give you a chance to do the exercise. And when you unpause, I will then show you the answer. Okay, you've now unpaused, so I assume you're now ready for the answer. So let's have a play. So if you've had a look through the options in handling strings with R, indeed if I click on this now, you can basically have a look here. You can see there are many different things you can play with. So %s is a string, %d is an integer, %0 number d, so %0 3d would be 3 width integer with zeros leading, floating point numbers, floating points with decimals, and then we have scientific notation as well. Now let's play around with some things. So for example here, I'm just going to close my output.txt so it's not in the way. Okay, let's do a for loop for I in sequence from 1 to 10. So we're going to be looping from the numbers from 1 to 10. And one thing is do shift enter, and shift enter will let me print a new line. I can then do cat sprintf. What I'm going to try and do is I'm going to pad these numbers now, padding with zeros. So I can do %02d, new line, and I'm putting in the value I, close the curly bracket, and now you can see here we've done a loop, and we've written a 2 width integer with the first integer as a 0. So you can see for all of the numbers less than 10, it's padded it with a 0, but then for the number 10, we have the number 10. Okay, let's now try a really long, the same floating point number with different numbers of characters and different values after the decimal point. So in this case, we'll cat sprintf. We'll have it in a long format, which will be %12.8f. And then we'll do a short format, so this is going to be %5.2f. And so that basically means a 12 width float with 8 numbers after the decimal point, a 5 width float with 2 numbers after the decimal point, and we're going to basically put in 23 divided by 7 2 times. And there we are, we can see this is a 5 width with 2 numbers after the decimal point. Here we have a 12 width with 8 numbers after the decimal point. Finally, let's have a go at now writing a big number in scientific notation. So again, cat sprintf. We're going to do the age of the universe. That's going to be hopefully a large number. So age of the universe %E means scientific notation, and I'm going to put a question mark because I'm not entirely sure this is the right answer. And I'm going to say 14 billion. And now when we hit return, we can now see it's transformed this into a scientific notation. So the age of the universe, 1.4 times 10 to the 10 years. So that was the answer to the first exercise. Let's have a go now at the second exercise. So in this case, you want to create a file and then watch it as we're creating it. So first thing I'm going to do is I'm going to cat hello. And I'm going to cat that to the file called output.txt. I will then find it in the list here. There we are. And now when I click on it, you can see we've written hello. Now we want to append another line. So I'm just going to now do cat. And now I'm going to basically appending another line. ... There we are. So this is going to go to the file called output.txt. But now we do append equals true. And that way the new line will go on to the end. There we are, we can see it's popped up into the text file. Now if we want to overwrite the file, we will use append equals false. So if we can do cat, let's put a new string in, we'll do overwriting the file. So there we are, overwriting the file, ... New line, file equals output.txt. And now I'm going to set append equal to false. There we are, if I can type. There we are, we can now see the file has been overwritten. Be very careful when you're overwriting because it will just overwrite the file, and if you've used the wrong file name or the name of an important file, you will have just overwritten it. So okay, we've now finished with this part. Let's go back to here. So we've now finished with the string formatting section of this workshop. That means we can now move on to part 3, which will be looking at packages and CRAN. I look forward to seeing you in part 3.